Okay, so we start with Lab 5 for the first question. So the question asks for the value of AL in hexadecimal for each instruction. So right now we have 4 instructions and 8 lines. So we just proceed to copy the code and paste inside Microsoft Visual Studio. So we build the project and we go straight to F10. Okay, so for the first set of instruction, the first line said that we move the value of this binary into AL. So we just F10 that one. So if we check at watch, the new value of AL in hexadecimal is 61. So the value of AL is 61. So we F10 again. For this time and AL, so we know the value of AL is this 61 in hexa. So for n, we know that if the value is 10, it is 0, but if it is 11, so the value is 1. So we can just check if we just do it manually. So right here this 1 and 1, so the value is 1. So for 0 and 0, the value is 0. For 0, 1, the value is 0. So we check at watch, the value of AL is 0, 1. So 0, 1 right here. Then we proceed to the next set of instruction. So F10. This time we move the value of 12 hexa. So here 12. And then we move it again. F10. So for this time, we compare the value of 12 hexa and 3b hexa, and then we will get the value of AL. It's also 12. And then we go to the next line, the next set of instruction. So we move the value of this binary into AL, and we use OR with value 72 hexa. And if the difference between N and O is that if 10, the value is 1, and for 11 it is 1, and 00 it is 0. So if we F10 that, we will get the new value of AL, which is 7F. And then we go F10 again. We move the value of 83 hexa into AL, 83. And for this one, we XOR. For XOR, if I'm not mistaken, if the value is different, it is 1. But if it's the same, it is 0. So we F10 this one. It is A5 for the last set of instruction. Okay, so we continue with second question. So the question asks for user to enter a 32-bit number and use XOR. So we will just build the code and I will explain while we are F10ing. So we straight to F10. Okay, so str1, str2, str3 is the user prompt. It's basically a string variable, and val is the variable that store the value of 32-bit, and it is in D word because 32-bit D word, double word. And so the first line, we basically move the address of string 1, and then we call the user prompt, and call redact. Actually, we enter the number that we want. So for example, we enter the value of 3. Okay, and we will then move the value inside variable val. So if we check at our watch, the value of val is 3. And we go to XOR. in XOR, when we compare, if the value, let's say 1 and 0, it is different, so the value, the output will be 1. If it is the same like 1 1 or 0 0, the value stays 0, or 0 1, it will the value, the output is 1. So for this one, JP stand for jump parity, while JNP stand for jump not parity. So for this one, we will jump parity. Jump parity go to L1, so we go to L1. So call right bin. This basically display the value of 3 in binary. So we go F10, and then we move the value, the address of string 2, and then we call the string. Okay, so and then we go to jump out. Okay, so if we check our, okay, so right now this is the number that we enter, which is 3, and this is the number inside 32-bit binary, and it is an even parity because we have two value of 1, so even. Let's try it again, but for this one we use an odd parity. So we F10 again. Just move straight to correct that. So for odd parity, we will just say 1, and then we move the value that we enter into val, variable val. So if you check right here, okay, it is 1, and then we XOR, and for this one we will go to JNP, jump not parity, L2. So see, we skip the L1 and go straight to L2 because of the condition. And for call right bin, it will display the value of 1 inside in binary form, and then we call the address of string 3, and then we will display it, and we go jump to out. So if you can see, the 32-bit number is 1, and this is in 32-bit binary, and it is an odd parity. And that's all for question 2. Okay, so for question 3, we need to explain 3A and 3B. So we just F10 this question. Okay, so the first question asks if EAX is equal to 25, which conditional jump is taken? Please explain your answer. What is the final value of EBX? So first we need to move the value of 25 into EAX because we need to compare the value of EAX and 20. So if we move the value, the new value of EAX is 25. I'll just use this one. EAX supposed to be 25. Oh, but this one is in hexadecimal. Okay, so, and EBX. Okay, so we compare the value of EAX and 20. So EAX, so we basically compare the value of 25 and 20, and if we go to next line, we have JG stands for jump greater. So if 25 is greater than 20, it will jump to L1, but if EAX is smaller than 20, it will jump to L2. JL for jump less, so basically less than lah. So right now we know that EAX is bigger than 20, so it will jump to L1. So if we F10, we jump straight to L1, we skip JL L2, and we basically move the value of 1 into EBX. So if we F10, the value of EBX is 1, and we will jump out, go to the exit. Okay, so if EAX ini, so for this question, we get the value of ABX is 1 because EAX is bigger than 20 and JD is just jump greater, so 25 is bigger than 20, jump to L1, and then we go to jump out, we proceed to out and exit. And for the second question is, why is jump out instruction needed for this code segment? Please elaborate your answer. So if we don't have the jump out, we will proceed the code from L1, move, and go straight to L2. So let's say if we delete jump out, and then we build the project. Yes. And then debug start reload. Sorry, it's supposed to F10. Okay, so let's say we move, compare. This is the same because EX still is 25, so it will jump to L1, so move to L1, but this time we don't have jump out. If we just continue, it will proceed to L2 to move, to out, to exit. So if we don't have jump out, the answer will always be 0, because even if EAX is bigger, it will go to L1, it will also go to L2, and if it's smaller, it obviously will go to L2, so the answer will always be, the answer for ABX will always be 1. So that's why we have jump out. Okay, so we continue with question 4. The question asks to complete the three segment of codes according to the comment given. So this is the first code, second code, the third code, and the first thing for this one, it just display to calculate. This is the user prompt, so it will read what user input, so read that, and it is moved into ECX, and ECX is used as a counter for loop, and this is the call function. So if we see each function, it basically calculate the same thing but with different use of decrement or jump. So let's see for the first loop. This is the first loop. The question asks for the sum of ECX and put it into register EAX. So the first thing that we do is to declare EAX as 0. This is to ensure that there are no value inside EAX before we start calculating. And then we move the counter into EAX. I'm sorry, I mean add the value. So each time it loops, it will update the value of EAX. And then let's say if it's already 0, it will return the value. And that is for the first loop. For the second loop, okay, we have two addition. The first two addition of things that we need to do. So decrement and jump not equal. So same as before, we need to declare 0, and we add the value of ECX into EAX, but for this time we need to reduce the value of ECX by 1, and then we compare it with 0. If it is not equal, it will jump to L2, but if it's already 0, it will go to the next line. We just skip the J and E. It will go to return the value. That is for the second loop. The third loop is we need to use decrement and JECXZ. This one stands for jump equal to ECX is equal to 0. So let's just go to the code. Okay, so we move the value of 0 into EAX, we add the value of ECX into EAX, we decrease the value of ECX by 1, and let's see right here, if the value of ECX, we minus 1 right here. So let's say before we start this loop, the ECX is equal to 1. So 1 plus to 0, EAX it will be 1, ECX say 1. Right here, ECX is equal to 0. And then, since ECX is equal to 0, it will jump ECX equal to 0 to out. So we go to the out. This is out. So we go to this, we just return the value. If the value, let's say before the loop, the value of ECX is 2, so we add EAX with 0, 0 plus 2 is equal to 2, decrease by 1, so 1, and it is not equal to out, so it will go to the next line, it will jump to L3, so it will restart again. So 2 plus 1 equal to 3, then it will equal to 0, and 0 is we need to jump to out, so out and return. And that is the difference of each loop. But yeah, it is different. And let's just we try to run this code. So we build the project first. Okay, so it's up to date. We already update to the latest version. So we just go to, let's say we go to F10. Call for F10. F10. Okay. So it will ask us to input our end, but it will be moved into ECX. So what we enter here will be the counter that we will use inside ECX. So let's say we put 3. We just run here. This EAX move to ECX, and then we new line, and this basically we call for all the function that we use. Then we wait. Okay, and this is the output for question 4.